All right, let's go over some of the electrical components that you're going to run into working on these gas furnaces. So, if you don't have a good working knowledge of electricity, you're going to have a hard time working on these. But the thing I like about gas furnaces is it really helps for a student or technician to learn how to use their meter and how to troubleshoot, which then bleeds over into air conditioning and uh, electric furnaces and all sorts of other things. But it seems like it's a lot easier for students to understand it on a gas furnace because they do follow a pretty simple uh, pattern. And so once you learn how to use that flow chart and then you use your meter to check these components, I think that bleeds over into other things a lot better and helps you learn how to troubleshoot, helps you learn a process. So the biggest thing is you've got your high voltage and your low voltage side. So you've got your incoming power, which is usually going to be 120 on these, and so you're working with pretty low voltage. You don't have a lot of high amperage components. The biggest thing you're really going to deal with is your motor. So it's not like working with compressors and heat strips. And so you're going to be working with 120 volt and 24 volt typically on most of your gas furnaces. Thermostats, again, just on a furnace are pretty basic. You're working with just a red and a white usually. You may have a blower function. Now, if you have an air conditioner, then obviously you're bringing in yellow. And then if you have a two stage, you might be bringing in a Y2 as well. But as far as just the furnace itself, you're simply bringing in red from the transformer into the stat and then sending that back out on white when you call for heat. And then your furnace board is going to do most of the work at that point once it gets a call. So pretty basic. And that's where you'll see a lot of simpler thermostats than maybe you would see on a heat pump. You may see some of these even mechanical stats or small digital stats that are like a round dial type stat. Those are usually two wire stats that are just, or maybe they have cooling as well, but pretty simple thermostats, and that's really all you need for most gas furnaces. You can still use higher end stats as well. You could use a heat pump stat or whatever. You just wouldn't be hooking up all those settings, and you would be making sure that you set it up for a conventional heating setup. Your relays, you still may see some of the same relays, but honestly, a lot of your relays are going to be built into your furnace, and so you're not going to be dealing with individual components as much as you're going to be dealing with relays and switches that are built into a board. And so it's still the same principle. It's the idea that I know that something's supposed to be sending power out, and as long as I'm sending power to it and I'm giving it a call, then I should see the result of that. But you kind of got to work through that board sometimes, and so keeping these components that we've learned in the past kind of in your head, but sometimes you may not see that exact component, but you're still going to see normally open, normally closed switches. You're going to see coils that are calling for something. So just knowing the difference between a load and a switch, and then knowing like with your boards, if it's getting a signal to work and it's not working, then you can check those relays and see what's going on with it. And then a lot of times it's just a board that needs replaced or something. So um, your board is going to control your fan as well. So you could control your fan on setting with G if you had that, but as far as the blower itself, that's going to be a part of your sequence, and so that's going to be one of the last things on, and that's all the board. The board's doing all that. And then a lot of your safety switches, just knowing again how to check those switches. And so some of those may be your high limits, your auxiliary limits, your rollout switches. Anything that's going to trip the unit out or trip certain components out if something were to overheat, or if you get a flame somewhere you don't want it, or you lose a draft, or pressure switches, for example. And so a lot of switches that can open and close in the event that something goes wrong. And so just checking those for power passing or not. So here's an example of some of those. Some of these are these rollout switches, for example. If you have a manual reset rollout switch, that's going to be something that uh, is going to have to be, the button's going to have to be reset manually when you get there. And that's an indication that maybe you have a flame coming into the uh, burner box instead of going down into the tubes. It's coming out. And then you may see these non-resettable links, these fusible links. You'll also see these in electric furnaces as well, but these are like a non-resettable. Basically, if they open up, you have to get a new link. You have to purchase that. So it's kind of a last-ditch effort, but you might see those as well. Just a couple of different styles. But again, those are not automatically reset, because if that is getting a flame somewhere it doesn't want to be, they don't want that tripping out or closing back and allowing it to run again. Your pressure switches, basically 24 volts coming in, and then once it establishes a draft, it's going to send power on to the board and indicate that we are getting a draft. Your inducer motors, now these are going to be your loads. These are usually going to be 120 volt motors. They may be different type. They could be a PSC, they could be a shaded pole, they could be an ECM motor as well. So knowing how to deal with each of those individual types of motors is going to come in handy when you're troubleshooting. Your gas valve has a solenoid on it that has resistance. It's a coil. It's going to consume power. Now there are switches built into it too. That's kind of your on-off switch and such. But as far as the solenoid itself, that's a power-consuming component. So that's got to be energized, and then that's what's going to open up your valve or close it if it's not getting a call. Thermocouples, you'll see these more on some of your hot surface or standing pilot type lights or power pilot. This is just kind of like a flame proving rod, similar to what you have in your main burner, where you have your flame sensor. It's going to send a signal back to that just to let it know that that pilot's on. So I'm not going to spend a lot of time on that. We'll talk about those later in lab. Igniters, again, different types of igniters, and so you may have spark igniters, hot surface igniters. Hot surface is going to be a resistance type element that's going to heat up, and it's going to get hot enough. It's probably going to glow orange or red, and it's going to get hot enough that it's actually going to be able to ignite that gas without an open flame. And then you also have your power, like a power pilot that can use a spark to light the pilot. And we talked about boards earlier. So I know I'm going through this quick, but it's just basically introducing you to some of the things you might see. So some of the boards, it could be a kind of an aftermarket board, Honeywell, White Rogers, something like that, or it may actually be something that looks more like these that are built for that particular piece of equipment. But that's going to control everything. That's your brains of the entire furnace. And so it's essentially getting a call from red to white, and then white's coming back into the board, and then the board's doing the work at that point. Your flame sensor is essentially a rod that is actually picking up a small current when the flame passes across it, that through a process called flame rectification. And that, again, is sending a signal back to the board so that the board knows that there is a flame in the burner present. So it's not going to keep spilling gas into that burner cabinet if there's not a flame. So it's going to kick that gas valve off. So again, it's a safety as well. And then your blower motor is your biggest component, obviously. You've got PSCs that are going to have a capacitor with those, and so those are like any other capacitor-driven motor that if that capacitor goes bad, if that capacitor is getting weak, then that motor is going to struggle to start, or it's going to overheat, it's going to get too hot, it's going to act sluggish, or maybe not even turn at all. So that's always something to keep in mind. And then you also may see more and more ECMs. These are your variable speed or your multi-speed ECMs, your constant airflow or your constant torque motors, and those are going to have a module on them that's going to help drive that motor. So again, we're kind of going through this pretty quick, but let's see. And then one of the last things that may come into play, and a lot of times we kind of overlook it because we don't even really think about it at that. Once we get the furnace firing, we think we fixed it. Now this is an older style. This is what they call a fan limit switch. But I really just want to focus on the limit part. The limit switch is one of the last things that can go off, that can take a system off, and sometimes that can happen maybe even after we've left. So once everything fires, if that box is getting too hot, then that limit can actually trip the system off. And so if you have a unit that's tripping off on a high limit, usually that's an indication of an airflow problem. And so that's where if you're doing your temperature checks, your temperature rise across your furnace, that's maybe a good indication that you've got an issue if your furnace is getting too hot. And so before you leave, it's always a good idea to get a measurement of temperature rise, what type of supplier you're blowing out. And if it's too hot, then you're more than likely going to be tripping your high limit. So that's something that I think a lot of people overlook because once we get the furnace firing, we think it's fixed, and that's not always the case. And so that's going to pretty much cover what we're talking about here. It gets into pumps and things in this chapter as well, and we're not going to spend time on that right now. So hopefully that helps.